All right, this is assignment 6H. This is going to be a little bit more broad than the previous couple assignments. So we're kind of coming to the full picture of what this chapter is, all in the same type of assignment. So let's see what we have to do, and let's use the formulas that we need to use. All right, so a director at a health club conducted a survey and found that 29% of its members used only the pool for workouts. Based on the information, what's the probability that a random sample of 12 at 5 only used the pool? All right, so we don't know like the actual frequencies. I just know a general probability of a success happening. So I see that the total number of members is 12. The number of specific successes is exactly 5, not like 0 to 12 or anything. I'm only asking for the number 5. The probability of them using the pool is 29. That would be failure to be 71. The formula that I'm using to achieve this is probability of a certain number of successes is NCR, P to the R, Q to the N minus R. And I have to put some of my own parentheses. Let me minimize this and then let's get to work. Shrink. Okay, so in this specific problem, I'm going to just set it up in that one, so I don't need a list or anything because I'm not asking for multiple probabilities. I'm just looking for the probability of 5. So the probability of 5 in this situation would be 12 comma 5, 0.29 to 5 times 0.71 to 12 minus 5. Easy. Okay, this is the same kind of concept down here, but notice how they're asking multiple probabilities at once. So this is where I kind of need to start using my lists. All right, so the total number of mountain climbers here is 13, making the number of successes 0, 1, 2, all the way up to 13. So a lot of these probabilities are going to be itty bitty teeny tiny. Probability of success is 62, and failure is 38. The formula that I'm using for all of this is NCR, P to the R, Q to the N minus R. I have to put that bit on my parentheses. Okay, again, make sure you start these lists with 0. Don't start them at 1. Okay, make sure those lists start at 0. Okay, so again, notice how a lot of these probabilities are itty bitty. When the number of things that you're using, when this R is like kind of like a large number of numbers, these individual probabilities are going to be tiny because they all add up to 100% or 1. So they individually have to be relatively small. So be heads up about that. So be comfortable with using this E notation. All right, probability that all 13. The letter B. 13. Okay, so again, be comfortable with that E notation, 0, 0. Because the number is 3, that gets 2 zeros, and then I start the number. At least 10. No more than 3. These are going to be wicked, wicked small numbers. Okay, so for instance, this has 5 zeros. Right, like with a number 5, so I know how many zeros there are. This will have 4 zeros. This will have 3 zeros. This will have 2 zeros. So this is 1, 2, 3, 4, 5 plus 1, 2, 3, 4 plus 1, 2, 3 plus 1, 2 0, 0, 2 zeros, and a 5, 1. All right, exactly 11, 12, or 13. So 11, 12, 13. Because it's the word or, that means add. So this is very similar to part B. So this is the probability of R is greater than or equal to 10 minus the probability of 10, which I don't want on there. So again, this is part B, which was 10, 11, 12, and 13, which is exactly the question that I want, except I don't want the 10 onto that number. So I'm just going to take the 10 off of that number.
Okay, again, this is one that is very much over, like, people think about this way too hard. A coach found that 12% of hockey games end in overtime. What is the expected number of games to end in overtime if a random sample of 50 hockey games are played? So if you play 50 hockey games, 12% of them end in overtime. Okay, that is 12% of 50 hockey games. Okay, don't overthink that one. 6 games. Okay, here we're looking for the number of successes. So what I have in this situation is N is what, 5 trucks. So the number of successes is 0, 1, all the way up to the number 5. The probability of success out of this is 65%. That means failure is 35%. The formula that I'm using for this general probability is NCR, P to the R, Q to the N minus R. I have to put that in here. All right. So this will have 2 zeros. All right, so this is a unique problem here. We haven't seen this one before. Find the mu of this probability distribution. That's the expected number. So looking at the formulas that we know, we have mu is equal to the sum of x px. We have something that looks like that. So it's not that hard of a stretch to understand that that would be like r PR. Right? So if you think about this, this is list 1, that's ours, that's what we did, 0, 5. And then we stored the probabilities of those as list 3. So this is just the same thing, just with a different context. And so this is going to be the sum of R, which is list 1, PR, list 3. Okay, I'm going to store that answer as the letter U because the very next question is asking what is the standard deviation. And so that's sum, open, X, or in this case R, minus mu, closed squared, Px, or aka PR. If you write X's, I totally get it. I do all the time. just like how we did on the first part of assignments.